Alright guys, good afternoon. So I know it's a little late notice guys, but not really above the weather these days and digital playing up, so we can't do no lives. So you have 20, 15, 16, 17 the specimen paper, 18, 19, 20, and I'll get the 21, and you'll get these videos back to back. I'll do as much as I could, half an hour per video. Repeats are not doing no working at all. Go back in the previous papers for the repeats. So let's start. X minus 2 is a factor of that. Just put x is equal to 2. This was a repeat, so I just double checking, making sure that the answer is indeed A. So 4 into 2 to the power of 4 minus 2 into 2 squared minus 56, supposed to be 0. We get 0. The answer for this is A. This is equal to, again, these questions might vary, but this one is definitely a repeat. I rearranging it one time. AB minus 3B minus AC plus 3C, B into A minus 3, take away C into A minus 3, yeah, A minus 3 into B minus C, answer is D. If x squared is that, if that is equal to that, then A, H, and K is, so you have a couple ways to do it. Easiest way, ax squared plus bx plus c is equal to a into x plus h squared plus k. A in the quadratic will be equal to a in the completed square version. So in this case here, a will be 1. So the answers here will be either A, B, or C. H is equal to B over 2A, which is equal to, in this case, B is minus 6 over 2 into 1, and I get minus 3. So B could only be the possible answer for this one, and K is equal to C minus A H squared. C in the quadratic is 13, minus A was 1, and H was minus 3 squared. So this will be 13, take away 9, which will give me 4. So B confirms is the answer. Use these formulas. A is A, H is B over 2A, and K is C minus A H squared. Remember it, memorize it for your completing the square if it comes in a multiple choice. The roots of the equation are, you have a calculator, go ahead and solve it. Mode 2, 3 minus 6 minus 5, 3 minus 6 and minus 5. Real root, real and distinct. Remember, if it's the xy on top here, then it's an imaginary root. The values of x for which that is equal to 64x are, brother man, you could solve, or we can substitute the values one time. So I'm going to check and see if 3 is an option. So I have what we could do this: x plus 15 squared take away 64x supposed to be 0. I just rearrange a little bit. I substitute in 3, seeing if 3 works. 3 minus 15 all squared minus 64 into 3 is not 0, so 3 is not an option. I'm gonna check 5, so I know this cannot be and this cannot be here, so I'll check 5, 9 and 25. If that makes sense, I check 9. If I check 9, it could be either B or D, so I'm just gonna check 5 or 25. So when I check 5, I get 5 plus 15 squared minus 64 into 5 is 80, so the answer could only be D. So when I check 25, 25 plus 15 squared minus 64 into 25, we get 0. So the answer is D. Number 6, the range of values for x squared minus 7x plus 10 is, so I've seen I'm going to solve this quadratic, right? I've seen 2 and 5 could be solutions, minus 5 could be a solution as well. So I'm going to check and see what's the solutions to this quadratic. 1, minus 7 and 10, 5 and 2. So I know this quadratic here, it is a positive x squared, so you're going like this. I want to know where it is less than 0, it's underneath. This is 2, this is 5, less than 2 and greater than 5. See? This is another repeat as well. I think this one is x is greater than minus 2. Yeah, this is the repeat, x is greater than minus 2. F of x, g of x, g f of x. So I want to know what g f of x is, which is g of 2x minus 5, which is equal to 4 plus 3 over 2x minus 5. And they did simplify it. So an easy way to simplify it, cross multiply here, this is over 1, and then multiply the two denominators. 4 into 2x minus 5 plus 3 all over 2x minus 5. They did simplify it further. 8x minus 20 plus 3, minus 20 plus 3 could be minus 17. So 8x minus 17 on top. A could be the only answer. The range of f of x is, so they didn't give us a domain, so this function will be, the range of this function is going to be from the maximum or the minimum point all the way up to the infinity or negative infinity. How range works, range is tied to my y-axis or my vertical axis. I'm gonna show you. X squared plus 4x minus 21. Let me see what we can do here. X squared plus 4x take away 21. That is one quadratic I draw there, right? I am going to draw another one. Minus 2x squared plus 3x plus 5, I guess. So I'll deal with the green quadratic first. Domains are tied to the x-axis, while ranges are tied to the y-axis. The range just says, where does this graph exist on the y-axis? Well, this graph exists over from here all the way up to positive infinity. Whereas the blue graph will exist from here all the way down to negative infinity. So your maximum and minimum points will come into play, depending on the domain they give you. In this particular question, they didn't give us a domain. So I know this will be a minimum point, so it will be from the minimum point upwards. So to get the minimum point, I'll just differentiate and put it equal to 0. When I differentiate x squared, I get 2x plus 4 is equal to 0. And I get 2x is equal to minus 4 and x is equal to minus 2. Well, the only thing that has minus 2 in it is this here. That's the only function that has minus 2 in it. They did ask for the range of f of x. And from the graph, you can see that the range, oh shucks, sorry. Boo-boo time. This is my x value. F of minus 2 is equal to minus 2 to the power 2 plus 4 into minus 2 minus 21. I get 4 minus 8 minus 21. I double check. 4 minus 8 minus 21. Oh good lord. 4 minus 8 minus 21 minus 25. So this function will exist, based on the graph here, the function does exist from minus 25 upwards. So this function will exist when f of x is greater than or equal to minus 25. F of x will be greater than or equal to minus 25. Alright, so a little boo-boo I make there. I jumped the gun. I don't want to know where x is. I want to know where f of x is. The function that then m of this is a similar one to the h of something. M of x is 5 plus 2x, and we want to know what m of 4 minus 2a is. 5 plus 2 into 4 minus 2a. 5 plus 8 minus 4a. 5 and 8 is 13 minus 4a. That f inverse is equal to, all right. It have easy ways to do this, and then it have a mathematical approach you can do it as. We can trial and error this question. We have f of x and we have options for f inverse of x. Let me make life a little simple. All right, understand what I'm doing here. Similar to what I did, something I wanted to do in the last video. F of x, the operation that takes me from domain to codomain is f of x, and from codomain back to domain is f inverse of x. Now I can pick a value to substitute for f of x in this particular case here. So I want to pick a value of x that could give me a nice number. I'm not going to use 1 because I'll get a third. I'm not going to use 2 because I'll get 2/3. I can use 3 if I wanted to, but I see here I have fractions as well. So an easy number to use, if I use 3 here, I'll get 3/2, 3/2, and 3/2. I want to kind of break from that, so I'm going to use 6. If I use 6 here, 6 here, and 6 here, I'm going to get whole numbers to work with. So I'm going to substitute when x is 6, what is f of x? So I'll get 2 into 6/3 plus 5. 6/3 is 2. 2 plus 5. 2 plus 5 is 7. And I get 14. Now, when I plug in 14 into each one of these functions here, I suppose to get back 6 as my answer. Whichever one gives me back 6, that's going to be the inverse of f of x. So when I plug in 14 here, in the first one, I'll do it on my calculator. I'll get 14 minus 2, 12 by 3. 36 divided by 5, not going to give me 6. Let's do the second one. 14/2. 7 minus 5 is 2. 2 by 3 is 6. So the answer is B. The value of x is, I think this one was minus 1/4. I could be wrong. Let me just double check. 3 by 3 to the power 3 to the power 2x is 9, 3 to the power 2 to the power x. 3 by 3 to the power 6x is 3 to the 2x. 3 to the 1 plus 6x is 3 to the 2x. 1 plus 6x is 2x. Move it around. 6x minus 2x is 4x is minus 1, and x is minus 1/4. Nice. Pi. Before, this was n, and the answer was C. They just replace the n with a pi. The value of this was minus 1/2. This was a repeat. Logs. Log of x cubed to base 2 is equal to 6. Move the 3 in front. 3 log of x to base 2 is equal to 6. Divide by 3. Log of x to base 2 is equal to 2. And use the law in the theta log. 2 to the power 2 is equal to x. And x is equal to 4. Alpha and beta are the roots. What is the value of alpha plus beta squared? X squared plus 3x plus 4 is equal to 0. This is a repeat. I think this was 9 or 1, either or. A is 1, B is 3, and C is 4. alpha plus beta is equal to minus b over a, which is equal to minus 3, and they want alpha plus beta all squared, which is going to be minus 3 all squared, which is 9. The common ratio of the GP, 12 over 8 12 over 8 12 over 8 1.5 or 3 over 2. Now if your calculator brings up that k, if you go back in the video and watch that k, just clear your calculator, right? I really dig up to see what that k means, because I just clear my calculator and start over. Sum of the odd integers between 10 and 50 is 600. For the AP, the nth term is given by, I think this was 5n minus 17. Let's check it over. Was it this one? Was it? Wasn't. It was 2013. Was it 2013? Yeah. 5n minus 17. Minus 12 minus 7 minus 2, 3, 8. Minus 12 minus 7 minus 2, 3, 8. Alright, 2500 over 3 for this one here. A line L passes through 6, 5 and is perpendicular to the line whose equation is that. The equation of L is Jah Rastafari. Alright, let me see how we could break this a little bit here. A line L passes through the point 6, 5 and is perpendicular to the line whose equation is this. If I could figure out the gradient of this particular equation here, which I'm going to do now, just trying nothing, 4y is equal to minus 3x plus 7, and y is minus 3/4 x plus 7 over 4. This is the gradient of this line here. The gradient of the line perpendicular to this, which is L, is going to be 4 over 3. So I'll go in and check and see which one of these lines will give me a gradient of 4 over 3. So I seeing if I rearrange this here, I will have to divide by 4 for this one to get y by itself. I'll have to divide by 4 for this one to get y by itself. I'll have to divide by 3 with this one to get y by itself, and I'll have to divide by 3 for this one to get y by itself. Remember, I'm looking for 4 over 3 because the product of the gradient of perpendicular lines is minus 1. So I'm looking for positive 4 over 3. So I am more gravitating to option D. Option D, when I rearrange, I get minus 3y is equal to minus 4x plus 9. When I divide by 3, y is equal to minus 4 over minus 3, which is equal to 4 over 3, which is what I'm looking for the gradient of a perpendicular line. Just a little breaks you could do to break the calculations. If you all want to see the calculations, I'll just make a little short on it. Just put it down in the comments now. If you all want me to explain anything that we did in this video here, just put it down in the comments. Alright, I'll respond to the comments trying to explain what I could. That and that intersect at the point. Well, brother man, that is simultaneous equations. Let me see which of these points satisfies both equations. This is my x's and this is my y's. I'm going to substitute the x. X is 4. When x is 4, y should be 1. That is 4 to the 8. 8 minus 7 is 1. When I plug it in here as well, I am plugging in the x and the y. I'll get 4 plus 3 is 7. So the answer is A off the bat. Alright, just substitute the points into it. Or if you want, you could go ahead and solve them simultaneously if you want to. Right, nothing wrong with that. Let me just do it quick for the simultaneous equations and enthusiasts. So I have 1 and I have 2. I'm plugging in 1 and 2. So wherever I see y, I put in 2x minus 7. X plus 3 into 2x minus 7 is equal to 7. X plus 6x minus 21 is 7. 7x is equal to 7 plus 21, which is 28. 7x is equal to 28, and x is 4. The only option that has x is 4 is part A. A circle has center 3, minus 2, and radius 4. The equation of the circle is, alright, sometimes this particular format of the circle is easier to see. Others will see it like this: x minus a squared plus y minus b squared is equal to r squared. And then we go expand. To me, this is an easier way to see it for questions like this. Expand it, use the shortcut x squared minus 6x plus 9 plus y squared. This becomes a plus inside of here. That is plus 4x plus 4 is equal to 16. So I have my x squared, I have my y squared. Minus 6x plus 4x is minus 2x. Yeah, minus 6x plus 4x is minus 2x. Any of these here have minus 2x as an option? No, it doesn't. Did I make a mistake? 3 2s are 6, 2 2s are 4. I didn't make a mistake. Center and radius 4. Oh shucks, this supposed to be 4y. My bad. Alright, so I'm looking for minus 6x, check, plus 4y, check. So this could be the only option here. C is the only option. This is plus 6x and minus 4y, which I'm not concerned with. I'm looking for minus 6x and plus 4y. Two vectors are equal if they have the same magnitude and the same direction. We did this question already. This answer is C. Which of the following statements is true? 5 2, this one was perpendicular. Go back in the last video, you'll see it. This one I think was minus 1 on root 3. I'm gonna check back. This one was minus 1 on root 3. This is trig, so trigs will be a little bit down here. Minus 1 on root 3. Right, look the solutions for number 26 here as well. So minus 1 on root 3 for this. This one was pi on 5. This is another repeat. Pi on 5, yeah, I reminded. Again. I don't see, actually, part D looking, no. One revolution, nah man. Oh, sorry, sine of x. I kind of gauge it as sine of 2x. Sine of x is going to be part D. The smallest possible value. I think we did this one as well, you know. Wait, nah, I didn't do these questions here. Oh shit. Alright, I didn't do these questions. 31 is a repeat. 31 is this. 4 pi on 5 radians. This was 144 degrees. And this was tan theta is adjacent over opposite over adjacent, sorry, minus 5 on 12. My bad for that miscommunication there. Let me just do the working for number 31 is a repeat. It's definitely a repeat. I think that repeated from one of the papers before, 100%. Let's go down to the trigs. Yeah, alpha plus 45. Alpha plus 45. Then 4 pi on 5 radians. I think that was a repeat as well. 4 pi on 5 radians is 144 degrees. And the last one, sine theta is 5 on 13, is a repeat as well. Minus 5 on 12. So you have the working for that. Alright. Yeah, so this was a repeat. The smallest possible value. Yeah, pi on 3 was the answer. Look, this repeated again. 1 on root 2 sine theta minus cos theta. Just now, it's alpha plus 45. This one is alpha minus 45, right? So it'll be sine alpha minus cos alpha. It's the same approach, exact same approach. Use your compound angle formula. 144 degrees, 4 pi on 5. Let's just double check. 4 pi on 5 is 144. So you're seeing what repeating plenty, yeah? Minus 5 on 12. This repeated as well. Sine x over 1 minus cos x plus sine x over 1 plus cos x, 2 over sine x. The differential of this, the first derivative, going to be 7x squared plus 4 to the power of a half. It's a half into 7x squared plus 4 to the minus a half multiplied by 14x. So I'm looking for 7x on top. These two give me 7x on top, and I'm looking for this below alone. The square root of 7x squared plus 4 alone. 7x squared plus 4. So the answer is B. At the point that the curve y is equal to f of x, dy dx is equal to 0. So if dy dx is 0, well, brother man, is a turning point. If d2y dx squared is negative, that means negative vibes again, so it's a maximum point. Cos 2x dy dx is minus 2 sine 2x. This is a repeat. Dy dx, this is a repeat. Yes, this is a repeat. If I remember correctly, this is d x squared over x plus 3. If it didn't come here, it came in the previous one, in the previous year. X squared over x plus 3, x into x plus 6 over x plus 3 squared. D. The curve C with equation y is f of x has a stationary point at minus 2, 5. If f double dash x is equal to x to the power 4 minus 15, then minus 2, 5 is, so the stationary point occurs when x is minus 2. So when I substitute minus 2 over here, I get minus 2 to the power 4 going to be 16, minus 15 is 1. So f double dash x is greater than 0, which means it's positive, which means we're happy, which means it's a minimum point. Number 40, if that where a is greater than 2, then a is, oh Lord Jesus. We could substitute. I think the easiest thing to do here is to just integrate and solve. I get 6x plus 3x squared over 2 evaluated between a and 2 is equal to 72. There's a. Substitute a. I get 6a plus 3a squared over 2. Substitute 2. 6 into 2 plus 3 into 2 squared over 2 is equal to 72. All right, so I'm finishing the working here. 6a plus 3a squared over 2. Take away, that is 12. I'm going to work out the second bracket here. 12 plus 2 to the 4. 4 3s are 12. 12 over 2 is 6. So I get 18 on the next side is equal to 72. So I get 6a plus 3a squared over 2 is equal to minus 72 plus 18. Well, 72 plus 18, 90. If I multiply throughout by 2, I get 12a plus 3 a squared is equal to 180. Rearrange 3a squared plus 12a minus 180 is equal to 0. Plug it in a calculator and solve. Mode 2, 2, 3, 12 minus 180. They say a is greater than 2. So 6 is the answer, minus 10 is the answer, minus 10 is less than 2, so the answer could only be 6. This one was a bit of working. The region bounded by the curve y is equal to x squared. This is a repeat. I could already see this here because they're looking for the volume of the solid generated, which is going to be pi y squared. And y squared is x to the power 4, and you must have a pi in the integral as well. This is a repeat, 2x minus 5 cubed. Is it a repeat? Is it a repeat? Is it? Is it? Yeah, boy. Look at here. Is it the integral of 2x minus 5 cubed dx? Integral of 2x minus 5 cubed dx is 2x minus 5 to the power 4 all over 8. 2x minus 5 to the power 4 all over 8. If y is equal to 3x squared plus cos x, then the integral of y is going to be 3x cubed over 3. The integral, if the differential of sine is cos, the integral of cos is sine, so it will be plus sine x, this 3, so we get x cubed plus sine x plus c, b. I think this is a repeat as well. 3x squared plus cos x. It is a repeat. Looking like a repeat as well. Nah, that is not a repeat for sure. That is not a repeat. This one you gotta work it out. 1 plus x squared. Let me integrate it. We get x plus x squared over 2 plus x cubed over 3 evaluated between 2 and 1. Substitute 2 plus 2 squared over 2 plus 2 cubed over 3. Then substitute 1 plus 1 squared over 2 plus 1 cubed over 3. Let's look at the first bracket. 2 plus 2 to the 4. 4 over 2 is 2. Plus 2 to the 4 to the 8. 8 over 3. Shucks. Oh, good lord. 2 plus 2 to the 4. And 4 divided by 2 is 2. Plus 8 over 3. 6 and 2/3 is my first bracket. Take away 1 plus 1/2 plus 1/3. 1 and 5, 6. 6 and 2/3. 6 and 2 over 3. Take away 1 and 5 over 6 equals 4 and 5/6 is the answer. See? Lastly, the region R is enclosed by the x-axis. The curve that the lines that the area, so our area, the integral between 1 and 0 of minus x squared plus 2 dx minus x cubed over 3 plus 2x evaluated between 1 and 0. When I plug in 0, I'll get 0, so I'm just going to plug in my upper limit, minus 1 cubed over 3 plus 2 into 1. That is minus 1/3. There's a repeat question. There is 1 and 2/3 or 5 over 3. Alright, so I'm gonna start working on the next one time. Leave a like, leave a comment, share it up the place, and I'll see you guys in the next one. Peace.